Right. Welcome back to Optical Communication video lectures. In this video, we are going to discuss about the topic optical fiber connector. At the end of this session, you will be able to know about different types of connectors used in optical fiber communications. Okay. And then, what is the purpose of the connectors? Why we need connectors also? We are going to learn. And then, what are the properties required for selecting a good connector? If you are using something, it should be best. So, what are the properties that we need to select a better connector? And then, what is the difference between a ferrule connector and extended beam connectors? These two are the different types of connectors, and we are going to learn the difference between these two and where we are using them. Okay. Now, properties of a good connector. Now, what do you mean by properties? There's the characteristics. Okay. So, if a connector is to be said a good connector, what are the properties that are required for the connector to satisfy? Connectors must maintain similar tolerance requirements to splices in order to couple light between fibers efficiently, and they must accomplish it in a removable fashion. That means, reading between the lines, connectors must maintain similar tolerance requirements to splices. Means for different splicing techniques, you are going to learn about splicing in the next session. Okay. In the next session, you are going to learn about splicing. Splicing is the joint that is made between two fibers. Okay. So connectors must maintain similar tolerance requirement to splices. Means for different kinds of fibers, splicings, connector should have the same tolerance. It should not change its tolerance levels. Tolerance means ability to accept something. Okay, if there is a change, it should accept it. Okay, to splices in order to couple light between fibers efficiently. So coupling, what do you mean by coupling light? Coupling is joining light from one fiber to another fiber. Okay, what do you mean by coupling? Coupling is joining two fibers in order to make something transmit between those two. Okay, and they must accomplish it in a removable fashion. Connectors should help to remove. Okay, connector should help in joining a fiber and removing the fiber. Okay, now the connector design must allow for repeated connection and disconnection without problems of fiber alignment, which may lead to degradation in performance of the transmission line at the joint. That means connector should allow for a repeated number of connections and disconnections. If we are doing some experiment on optical lab, then we need to continue, we need to connect it, remove it, and then again next batch, and then next batch, and then next batch. And after this year, those connectors should be used again next year. Okay, the same kit should be used again next year, right? We can't buy new kit for every experiment. Okay, so connectors should support this repetition of experiments for different batches. So a connector should support repeated connections and disconnections. If you are doing some experiment, you need to connect the wire and remove the wire. So this connector should support the repeated connections and disconnections without problems of fiber alignment. What do you mean by aligning? Aligning is making or placing something in line. Okay. Now connector should not create any problems in fiber alignment. After a repeated number of connections and disconnections also, for the next time, if you are connecting it, like if you have done the connections and disconnections for 1,000 times, and if you are trying to connect again for the 1,001 time, then it should not change the fiber line. Okay, the input fiber and the output fiber should come in a line, which may lead to degradation in the performance of transmission line at the joint. If there is a misalignment, then there will be degradation in the performance. Performance is going to decrease. What do you mean by performance? Transmission of light signal from the first cable to second cable. And this is going to decrease if the two fibers are not in line. We are going to learn this in your misalignment losses. Okay. In the same unit, you are going to get the misalignment loss at the end. Okay. To maintain an optimum performance, what do you mean by optimum? Optimum means the required or necessary, okay, suitable performance. In order to have a better performance, the connection must also protect the fiber ends from the damage which may occur due to handling, must be insensitive to environmental factors, and must cope with the tensile load of the cable. That means to maintain optimum performance, in order to keep a standard performance, the connection must also protect the fiber ends. If there are fibers, optical fibers, in your lab experiments, you have gone through these optical fibers. Those fiber ends are very small, so they should be protected. Okay, they should be protected from the damage which may occur due to handling. If you are not handling it properly, if you are pressing the tip or doing something while connecting and disconnecting, then this connector should help. Okay, this connector should be protecting those ends. Okay, must be insensitive to environmental factors. What are the environmental factors that we are discussing? Moisture and dust. If moisture or dust enters into the optical fiber cable, then the light wave is going to get scattered. It's going to result in losses. So connectors should protect the optical fiber from environmental factors too, and must cope with tensile load on the cable. What is the tensile load? Sometimes we will place our load, like something, some object may be placed or some extra stress is applied on the cable. So connector should protect the fiber end from that extra load. The connector should ideally be a low cost component which can be fitted with relative ease. Cost of the connector should be very low so that we can purchase them whenever the original connector is lost. Okay. Now, classification of connectors. Connectors are classified into, fiber connectors may be separated into two broad categories. They are butt joint connectors and expanded beam connectors. Butt jointed connectors rely upon alignment of the two prepared fiber ends in close proximity, okay, to each other so that the fiber core axis coincides. Butt jointed connectors are the most widely used connector type. So here, butt jointed connectors are most widely used connector types. And why we are using these? Butt jointed connectors rely upon the alignment of the two prepared fiber ends. After making the two fiber ends, we are going to align them. We are going to make them in a single line. Okay. In these butt jointed connectors, transmission capability depends upon the line in which we are placing them. Okay. So that the fiber core axis coincides. Butt jointed connectors are the most widely used connector type. Out of the two connector types, that is extended beam connector type and the other one is butt jointed connector type. Butt jointed connector type is the most widely used connector type. The other one is expanded beam connectors. Expanded beam connectors utilize interposed optics at the joint in the order to expand the beam from transmitting fiber end before reducing it again to size compatible with the receiving fiber end. That is, in a expanded beam connectors, the beam light is going to be expanded from the transmitter side and then it is again compressed back to suit the receiving fiber. That is what we have said over here. Okay. We are going to show the diagram and we can clear this. Coming to the next category, cylindrical ferrule connectors. Okay. You can observe what is a ferrule. Ferrule is the attachment that is made to your optical fiber cable. Okay. The basic ferrule connector, which is the simplest optical fiber connector, is connector design. Here you can see two ferrule connectors. Ferrule is the thing that is attached to your optical fiber to hold them in place. The two fibers to be connected are permanently bonded in a metal plug known as ferrules, which have an accurately drilled center hole in their end faces where the stripped fiber is located. Here we are going to have a hole where the fiber is located. Okay. And they are going to be attached using a epoxy resin. Within the connector, the two ferrules are placed in alignment sleeve. This is your alignment sleeve. Using accurately machined components allows the fiber ends to be butt jointed. What do you mean by butt jointing? Jointing these two fibers directly. Okay. It is essential for the ferrule type of connector that the fiber end faces are smooth and square. Okay. In ferrule type, what we are expecting is fiber end should be smooth and square. That is perpendicular to the fiber axis. Here you can see the fiber axis. To this, the fiber ends should be perpendicular. This can be achieved by cleaving the fiber before insertion of the into the fiber. Okay, ferrule. This fiber before being inserted into the ferrule, it has been cleaved. We will show what is meant by cleaving. Okay, in the next slide you are going to see cleaving. Inserting and bonding fiber cleaving the fiber close to the ferrule end face. So these two should be close to each other. We need to maintain both, and then the extra thing that we need to add is polishing the fiber end face until it is flush with the end of the ferrule. It should be polished properly. Okay. Then capillary ferrule is manufactured from ceramic materials are widely used within the precision ferrule connectors. Such capillary ferrules have precision bore, which is accurately centered in the ferrule. Here, the device is made up of capillary, okay, ceramic materials. Final assembly of the connector includes the fixture of the fiber within the ferrule, using adhesive prior to the grinding and polishing for the end preparation. The ceramic materials possess outstanding thermal, mechanical, and chemical resistances characteristics in comparison with the metallic plastics. What? The ceramic materials possesses outstanding thermal, mechanical, and chemical resistances. Okay, ceramic materials will possess these thermal, mechanical, and chemical resistance characteristics. Hence, they are used in metals and plastics. The ceramic ferrule material is harder than the optical fiber and is therefore unaffected by grinding and polishing process, a factor which assists in production of low loss fiber connectors. So, ceramic ferrule material is going to assist low loss fiber connectors. Typical average losses for multi-mode graded index fiber is 50 by 125 core and cladding. Okay. And for single mode, it will be 9 by 125 core and cladding ratio. With precision ceramic ferrule connecting at 0.2 and 0.3 dB respectively. They are the losses. Numerous cylindrical sleeve ferrule connectors are commercially available for both multi-mode and single mode fiber applications. There are many connectors that are available for both multi-mode and single mode. Most of the common design types are straight tip ST, sub-miniature assembly SMA, the fiber connector FC, the miniature unit MU, the subscriber connector SC. These are the different fiber connectors that we can observe later. Okay. The common fiber connector types used for both multi-mode and single mode fiber systems are explained here. What are they? Multi-mode optical fiber connectors generally used within the data communications. Multi-mode fibers are generally used in data communication, that is in your LAN cables, transports, okay, automobiles and aircraft. We are using multi-mode fiber connectors with specific test instruments. Single mode fiber connectors are employed exclusively in optical fiber telecommunication systems. Okay. The majority of the commercially available fiber connectors are designed to specifications determined by international standard bodies. What are they? TIA, IEC, and American National Standard Units. They are the units that have given the standards for these types. These are the different fiber connectors. Okay, SMA fiber connector. This is used for multi-mode fiber data communications. Okay, FDD type will be of this type, and the loss that we can experience is 0.2 to 0.7 dB. Okay, this is a push-on, pull-off type material, and it is used for LANs. D4 is of this shape, and the loss is 0.3 to 1 dB. You can go through these losses. Okay, you can pause the video and you can go through this. There are other fiber types. You can observe them. Okay. Then expanded beam connectors. Coming to expanded beam connectors, we are saying that beam is being expanded and then again being compressed in order to get the alignment proper. Okay, expanded beam connectors are the second type of connectors which is shown in the following figure. Expanded beam connector consists of two lenses for collimating and refocusing the light from one fiber to the other. Okay, the use of these interposed optics makes the achievement of the lateral alignment much less critical than a butt jointed fiber connector. These are better when compared to your butt joint connectors. Okay. The longitudinal separation between the two mated halves of the connector ceases to be critical, which is achieved by the expense of more stringent angular alignment. Here the angular alignment should be maintained. Okay. Expanded beam connectors are useful for multi-fiber connection and edge connection for printed circuit boards. Okay, they are used for printed fiber circuit boards, where lateral and longitudinal alignment are frequently difficult to achieve. Okay, where there is a toughness in achieving the lateral and longitudinal alignments, we can use expanded beam connectors. With the help of a lens, we can align the waveforms. What are the terms that we have come across? Optimum performance, best or possible, most powerful. Tensile load, a measure of the ability of the load to withstand a longitudinal stress. Epoxy resin, an adhesive material used for holding the two fibers together. In the next video, you are going to see, we are going to learn about single mode fiber connectors. Okay. What are the questions that we can expect? Short answer types are single mode fiber connectors. Okay. And then the other one is mention the optical fiber connector types, different types of optical fiber. In the long answer type, we can expect a multi-mode fiber joints.